Hello guys, I'm come back. Okay, so a while ago, welcome to my YT channel. I forgot to introduce myself and to my channel. Oh my gosh. Okay, so a while ago, I solved two problems, right, regarding with the density and the weight and the mass. Now we go to the problems number 3 and number 4. Okay, all about gravity, fraction, and forces. Okay, like this. It's not difficult, it's not complex, it's just very basic and easy to understand and easy to solve. What I'm trying to extract here is the better understanding and better analysis of the problems. Okay, so that if we can encounter a little bit more complex, then we have an idea already what to do. Okay, like that. So that's it. Okay. Now we will start gradually from easy, average, above average, and little difficult. Okay, so like this is it. And then sometimes you can observe also there's a combination of physics and chemistry. Okay, so they will be mixing with each other and a little bit of trigonometry, geometry, algebra. Okay, just like that. Okay, as you can observe. Okay. Number 3. This is the question for number 3. I will read first. You lift straight up a 4-kilogram box to a height of 2 meters above the ground. The box moves at a constant velocity for the entire displacement. Oh my gosh. How much work did you do on the box? Okay. Now we need to remember the displacement and the distance before anything else. Okay class, when you use the displacement, that is considering the magnitude and the direction. Okay, the unit it's still meters or in feet, but it will account the negative and the positive. Okay, unlike distance, the distance will not account the negative thing. Okay, for example, if we have, what do you call that one? Graphical representation, right? Algebra, right? So we have this y-axis, y going downward, and x going to the right, and x going to the negative. Remember that one? And then x, horizontal axis going to the right will be positive, and x, horizontal axis going to the left is negative, right? So this is what we call in algebra quadrant. Quadrant 1, quadrant 2, quadrant 3, and quadrant 4, if you can still remember, right? Like that. And then we have the y-axis going upward will be positive, and then the y-axis downward will be negative. Now, if you will try to put that in a direction, okay, in a direction, so we have the north going up, okay, and then positive, and going down will be the south, negative, and the west will be going there, positive, and then the east will be going there, negative. Okay, something like that, the direction. Okay, that's gonna be the direction of our planet Earth. Okay, east, west, okay, north, south. The west, our identification will be the setting of the sun where it sets afternoon. For example, 5 o'clock in the afternoon, 6 o'clock in the afternoon. So it's setting there. Okay, sunset. Okay, for the west. For the east, sunrise. Okay, that's the east, E-A-S-T. So we have an identification for east and west, but we don't have an identification for north and south. So that's our small problem. Not really, okay, then we have to understand na lang siya if stated on the problem. Okay, because normally it will be stated, okay, the car moves 20 meters per hour going to the north. Usually it would mention man yun siya. So that is the involving siya displacement. Okay? Like the magnitude plus the direction. Okay? The magnitude meaning the distance covered. Okay, like this, that's displacement. Okay, and the distance will not cover really the direction. That's the difference. Okay, now if you use the displacement, for example, so we have the formula of work, right? So work is equals to force times distance. Now, if you substitute the displacement and then you remove the distance, it will become work is equals to force times displacement. Now, in the displacement theory and principle, we need to back up with the angle of inclination. The right triangle theory of Pythagoras theorem in algebra. We should remember that one because that's already displacement. Okay, it's not already distance at all. Okay, even though it will go up, it will go down, that's considered displacement already. The distance is only applicable in the horizontal. Okay, it's not applicable in going up and going down. That's not distance already, that is height. Okay, height or vertical distance. Vertical distance is also a displacement, but horizontal distance is not a displacement. Okay, like that, because it doesn't consider the negative, the positive, the north, the west, the southeast, the northeast, ganun siya. Okay, so ganun na siya. Work is equals to force times displacement. Okay, if it is in the horizontal, especially if you pull the, let's say this is my table, I will pull this by a rope, and this is a tensile force of the rope I exerted in the object, right? If I pull that one, so I have the applied force already, and there's a displacement already. Okay, we are concerned now for the displacement here, the positioning. Okay, from initial to final, something like that. Okay, so force times displacement is equals to cosine theta. Okay, ganun-ganun na siya. Okay, and then if you try also to push that there in the left, so it will become still cosine theta, but your angle will be used is already different. The angle of inclination. Okay, so at first you use the 0 degrees because it's position originally man siya, so there's no angle yet. Okay, when you push and then you give extra effort going to the left, and it will become 180 degrees. Okay, because it will go there somewhere along the way there. So 180 man siya, diba? So if you have this like this, graphical representation, 360 degrees overall, right? The half will be the 180 degrees, and you know, the vertical will be the 90 degrees. So we will use those angles, chuba chuchu, for this work is equals to force times displacement cosine theta. Okay? It depends also, if you get the height, also we have sine theta. Ganon. It depends on the situation, the problem really. Okay? But what I am trying to point out here is the displacement covers the angle of inclination. Okay? Like that. Okay? So it's in here also, and discussion that all the forces will be taken into account. The applied force, the action force, the net force, the resultant force, the friction force, the normal force, all kinds of forces you are going to familiar with. Okay, and then you have to analyze what will be happening if you push this table there. I have this table, right? So you will analyze that one. If you will pull that one, like it's blah blah blah, what will happen to the gravity? Ganun siya. Okay, question number 3. You lift straight up. Lift meaning going up, right? 4 kilogram bags to a height of 2 meters above the ground. Okay, the bags moves at a constant velocity for the entire displacement. How much work did you do on the bags? Oh my gosh. So take note, guys. A, negative 78.4 joules. B, 78.4 joules. C, 0 joules. D, 157 joules. Oh my god, joules. Remember, joules is equals to Newton meter siya. Okay? Because the displacement is meter. Okay? And the force is meter, and the distance is meter displacement. Okay? And the force is Newton. Newton meter is the joule. Ganun siya. Okay? Okay. Try to read this question number 3 by yourself and get a sheet of paper and solve it also. Okay? I doubt you are better than me. Wow. In solving this one. Okay? Try to figure out, write the given like this, and then try to think what is the best formula to be used for this problem number 3. Okay? Okay, very clear, right? Okay. The first thing to do is we need to write the data or the given for this problem. So, oh my gosh, let's get a sheet of paper. Okay, like this. Do not, what I mean is solve by yourself first. Okay, and then let's compare our answers. Okay, because it's very challenging to solve on the spot, right? Okay. So like this, okay? So, word is being asked in problem number 3, word, okay? So, we know that work is equals to force times distance for the normal movement only, okay? Without considering the displacement. This is force times distance, okay? And if you are considering the displacement, so we will change this into W is equals to force. Let's say small letter d for displacement, okay? We are now dealing with a vector quantity. The positioning from position A to position B, from final position to initial position, like this. That's why displacement and distance is not equal, okay? Like that. So it is the net distance siya covered from final position to initial position man siya. Whereas distance is really the total you have to add up. One, regardless to the positioning from point A to point B. That's the difference between distance and displacement. Okay, so I have to put here small letter d for displacement. Okay, work is equals to force, small letter d displacement times the angle of inclination, which is the direction, cosine theta. Why? Because we are dealing on the horizontal axis, cosine theta good siya. Okay? Like that. So work is equals to FD cosine theta. Okay? This one. This is our formula to be used. Okay, that's what I told you to memorize, okay? If it involves displacement, positioning, angle of inclination. Okay? Okay? Especially if the problem will really specify the displacement or blah blah blah, so and so. That is your first indication. Unless it's stated here, this distance, hindi kasi siya distance na sinabi. Okay, see? The box moves a constant velocity for the entire displacement shot. It's not for the entire distance. It's there already that you will have an idea, the positioning will matter here. Ganon in your brain cells. Okay, so how much work did you do? So there's a choices, right? So I given, okay, 4 kilogram bags. Okay. General lang siya, bags, whatever type of bags is it. Okay? So, ganon. 2 meters above the ground. Okay, 2 meters. Height siya, right? Height. Okay, above the ground. So, after having the data or given, you have to draw and illustrate to understand really what's going on with this problem. So, I have the bags here at the ground because it's stated in the problem, right? In the ground, like that. And there is a person who tried to lift this straight up, vertically upwards. So I have to put a person, like a drawing, something like that, okay, that he will try to pull this up, okay? And then the height it will covers is 2 meters. So, from point 0 to the ground, okay, to up, where it's reached the 2 meters height. So there's a displacement, Okay, so ganon. So the question was asked, how much work did you do on the bags? So work na, so solution na siya. So work is equals to the force. So what is the force here? Okay, analysis talaga siya, no? So the force here, this is vertically upward baya siya. Okay? So, di ba maglibog ka? Because so, there is a mass given. Okay, then how can I obtain my force and there's no pressure? Because there's already a formula of force which is pressure is equal to force over area, right? So, oh my God, how can I get the force? Because this is not a horizontal distance man good siya. Okay, this is vertically upward siya. So, there's a gravity thing. Okay, gravity. acceleration due to gravity. Constant will be used here. Always like that, forever and ever, amen. If upward and downward, there's a gravity thing to be used, which is 9.81 meter per second square in terms of metric system and 32.2 feet per second squared in English unit system. Okay, here metric kasi meters or kilogram, okay, like that. So since we know in my discussion yesterday that weight is equals to the mass times the acceleration due to gravity or the gravity itself. So weight is equals to m times g. Okay, this one. Okay, and now this is vertically upward, right? So the force downward, okay, will be equal to the weight because the weight also will be directed downward, right? So it's just equals the force that will go downward. Okay, so force is equals to weight automatically. Okay, force is equal to weight automatically in here. Right? Remember that always, forever and ever, amen, that if you will try to lift up and go and push down, force will always equal to weight. Always remember that one. But force can never be equal to mass. Again, if you are trying to lift something, anything, chuba chuchu, and then if you're also to push objects downward, chuba chuchu, your always force is equals to work because of the gravity thing. But you can never say force is equals to mass. Okay, because mass doesn't account the gravity. Okay, like that. So since we know technically that force is equal to weight, so we can already get the force. Okay, so that we can use that in our formula, which is work is equal to force times displacement cosine theta. O, ganon. So mass. Okay, mass of the packs is 4 kilogram. Okay. And then the gravity is 9.81 meter per second squared. Okay, I kahadlok because kilogram meter squared is the Newton. Okay, so as I was discussing a long time ago, over and over again. Okay, like this. Okay, class, it's gonna be like this. So, my gosh, 4 times 9.81 is equals to 39.24 newtons. Okay, 39.24 newtons. So 39.24 newton is also our weight, because we say force is equals to weight. Then, therefore, we conclude that the unit of weight is always Newton. If in metric, okay, like that, okay. There are other also, but this is the most common, okay, Newton, because it is the basic unit of force, Newton. It's not the dyne, it's always Newton. But the dyne can be used also if the given of the problem is dyne, okay, or in terms of grams, in terms of centimeters, okay, like this. So we have 39.24 Newton. Our weight. Okay, let's specify this is a weight, guys, because we have the work also is W. We will confuse all our W kasi siya. Work is equals to W and weight is equals to W also. To identify, let's just specify weight in word W-E-I-G-H-T so that to avoid confusion. Okay, like that. So we have now the Newton. So, substitute now in the equation, which is work is equals to force, 39.24 Newton. Oh goodness, Newton. Again, the distance covered in a vertical distance or the displacement. Okay, in here class, there's no problem to also consider distance for the displacement because it's not really changing the point of position. Okay? It's all straight man gyud siya god. So pwede ra sad siya distance. But what I am trying to explain, this is a displacement thing from initial to final because the angle of inclination will be considered here. Okay, like that. since the distance covered height or the displacement is 2 meters. Okay, and then cosine theta. Okay, so our theta or angle of inclination here is just equal to 180. Okay, like this, because it's in the horizontal shot, like this. Okay, so 180, ganun ganon. So it's not 90 ha, it's 180. Okay, nagsugod magud siya sa ground. Okay, it started from the ground. Okay, so 180 cosine, okay, my gosh. Okay, cosine 180 is negative 1. Okay, negative 1. Oh my gosh. So negative 1 siya. So negative 1 siya ha. So negative 1 times 2 times 24. So 39.24 times 2 times 1. 78.48 negative Newton meter. Okay, this is joules, or 78 negative 78.48 Newton meter or joules. Is this our answer immediately? Because this is negative 78.4 is also in letter A. It's very tempting, right? Okay. It's very tempting. But you analyze, guys. Me lifted up the backs, going upward. So that is positive. It's not negative. Because displacement, again, we are considering here. Okay? So this negative is not the answer. Okay? This is the opposite, the positive 78.48. Okay? This is the magic for science sometimes, okay? This is, the weight is 78.48. Joules is the answer, guys. It's not the negative. Because the negative is the gravity man, padulong sa obos. But you are lifted up man siya. So positive, as I told you earlier. Okay, when you go up, lift it up. So y-axis is in the up man siya. So 78.48 joules positive siya. So the negative sign will be negligible. Okay? Negligible. Okay? Or irrelevant to the concept here. Okay? So that's why it arrives now that the displacement is just equal to the distance in a horizontal siya. Okay, so that's why we'll never put cosine theta na siya in our general formula. Work is equals to force times distance. That's the reason behind. Okay, I tell you the reason why. Because actually it started from F, force times distance and cosine theta. Since you always take into account that is 180 degrees and the cosine of that is always negative, okay, and then in the distance, negative manggod siya is not considered, okay, because distance is a scalar quantity, okay, unlike the displacement, right? So that's why we have work is equals to force times distance lang siya, wala na siya cosine theta. You understand? If it is in the horizontal plane, in the ground, that's the reason behind. It comes from that original equation. Okay, since distance is only considering magnitude, negative sign is not an issue. So that's why it is force times distance. And the distance supposedly is negative 1, right? It's now positive 1. That's why force times distance na lang siya. Cosine theta is really neglected na siya. Okay? So I'm just showing you pala the root cause or the reason behind why we will use the force times distance now work lang siya. Okay? But I am trying to dig it out this because this is a vertical magud siya. Vertical or lifted up. So that's why I need to establish or to show in my discussion cosine theta. So if it is pushing only, I don't have to say cosine theta like this. Okay? I have to focus on the distance lang siya. Okay? Unless I have angle of inclination during my pushing and pulling. So I have to use also the angle of inclination. Okay? So here, very tempting. The answer is letter B. 78.4 joules. Because you lifted up a straight back going upward. And in the displacement, that is very essential, that is positive. Though, you get an answer of negative. Okay? Like that. So the answer will be positive 78.4 joules going upward. Okay? You left the object upward siya. Okay, this is the answer. Very strange, right? Okay? So most of the students will answer really negative for this. Sure. Because it will come out really for the formula. Okay, but still you have to think, Manggod. Okay, so the answer is letter B, 78.4 joules. Okay, this is the power of analysis na siya. So letter B. Okay, 78.4 joules. Correct siya. Okay, number 4. A 50 kilogram trash can. Where's my trash can? It's there, right? Okay. So just like this, okay? My trash can is there. Sorry, it's very far. Okay? A 50 kilogram trash can is pulled across a flat surface like this in a floor in my room. Okay? Via a rope. Where's my rope? I have to tie my trash can with a rope. Okay? With a 50 Newton applied force to the right. Oh my gosh. So this is to the right. So it's better also to demonstrate right, but no need because it's very easy situation manggod siya. Okay? A fractional force of 30 Newton acts between the surface and the trash can. Okay? So meaning pala, the friction is in between the surface of the floor and the trash can. Okay, the object. Okay? The can is pulled for a total of horizontal displacement of 10 meters. See? Using the word displacement. Okay, so it accounts the negative sign, the positive sign, negative sign, the positive sign, like that. Okay, since you are pulling that one to the right, expected positive answer for the applied force and the action force, right? Unless you are trying to push that to the right. Sorry, to the left. Okay, because to the left will become negative man siya. Okay, because of this displacement. Okay, question number level 1 for this number 4. How much work was done by the applied force on the trash can? Charot. A, 500 joules. B, 0 joules. 4. C, 4 ba siya? C, 400 joules. D, none of the above. Okay, so let's illustrate na siya. Okay, let's go directly because it's the same thing man siya talaga that we need to put the data. Like this, okay. Okay, so ganun siya, no? Oh, where's the paper? This one. Read the problem first. Okay. Okay. So, you already get a sheet of paper, then write the problem by yourself and solve also by yourself. Okay? So, question number 1 for this number 4. How much work was done with applied force on the trash can? Since you are pulling, right? Pulling ba siya? Okay, pulled siya across. And this is a word displacement. So, angle of inclination. If there's a displacement man siya, no? So, it's not distance. So, displacement ang term. Okay? So, we need to consider the angle of inclination for the word. So, that's the first identification na class. If you meet a problem regarding force and there's a word displacement, bingo. Consider the angle of inclination. The work is equals to force times distance cosine theta. Ganon. Or it depends, tan theta ba siya, tangent theta ba siya, but most of the time, cosine theta because it is in the horizontal ground surface. Now, if it is vertically upward, no need to use that cosine theta anymore or angle of inclination. Just use the force times distance automatically but applying the gravity thing, okay, in getting the force. And treat force is equals to work. Ganun lang siya. And the rest will be following the rest. I think kasi tutuwaran pa siya, okay, you can already extract the point for the concept and theory. Okay, like that. So I need a sheet of paper. Okay. Ay, yung kahit na kung tuwa-tuwa siya. Okay, libog naman yun mo as a problem. Okay. So just stick with the basic theory and principle. Okay, like that. Okay, now work is equal. My goodness. Work is equals. I have to draw pa. Illustrate, right? To clearly understand what's going on. Okay, Trashcan. Charot. Trashcan talaga. So, if Trashcan, what kind of Trashcan is this? Okay, this is a Trashcan. Okay, 50 kilogram. Okay, and then pulled across the flat surface. So the direction will be away from the Trashcan, of course. Okay, because across surface man siya. Pulled man siya. Okay, like this. 50 kilogram. So this will be our applied force. FA. Applied force, guys, is also an input force and action force. Don't be confused. It's only the terminology is English, because sometimes it will use like this. The action force like this, the input force like this, like this. So, but it's the same. Applied force, action force, and the input force is just the same. Okay? It was just used interchangeably on the problem. Okay? Like this. So applied force will be, or input force, or the action force will be 50 Newton. Okay? 50 Newton. And the weight of the trash can, sorry, 5 kilogram lang siya pala. Okay? Applied force is equals to 50 Newton. Okay. Mauni siya. Okay? Then I have to pull by a rope. O rope, ganon. Let's say si Sotero. I pull this trash can here. Okay? I draw a person pulling the trash can. Oh, ganon. Okay, the weight of the trash can is 5. Like this. And the force applied is 50 Newton. Okay. And then, illustrate na talaga siya, guys. All the forces will act as much as you could. Okay? So, the opposite force that resists the applied force will be the fractional force. Okay? The frictional force or the fraction will act opposite in the applied force. So the direction will be in opposite direction. So it's gonna be like here, going there, on the left. So this is our fractional force. Our fractional force here, or the opposing force, or the resisting force, is equal to 30 Newton. Okay? Why I tell you that it is an opposing force and, restricting force like that? Because sometimes the problem will not use the word fraction all the time. Okay? This is also matters if you have a good English capability, comprehension in the problem solving. I'm not telling you that those people that are good in English are advantaged, but there's also a percentage that to be like that, because if you are good in English, you can understand also the terms being declared and reflected in the problem solving. Now, if you have a weak terminologist understanding, then sometimes, you know what I mean, okay, because you are limited only to that kind of term. Sometimes in a problem solving, they change the term into another term that has the same thing, or that has the same meaning. Okay? So, I'm telling that the examinees that are good in English has also an advantage in interpreting the problem. I'm not telling you all, but some or most, because the questions are declared and presented in English language. Okay? And sometimes the terms, using difficult terms, but the same meaning with those common terms that during our discussion in your college are using. Okay, then if it will change now in the examination, then you will be shocked. What's this? This is another term. So no more time to have the dictionary. Okay, no more have time to scan the dictionary when you go on the examination. Okay, you get the point. Okay, so fractional force, opposing force, okay, restricting force, like that is the fraction. Okay? Like that. So, 30 Newton. Because if we will just waiting for the fraction to appear in our problem, we are very literal. Okay, we are dependent only for the term fraction. What if the term fraction is not mentioned there, but the problem is stating only the opposing force is 30 Newton, but it's the same, that's the fraction because it's opposed to the applied force. Things like that, okay? So, very useful in the analysis of the problem. Okay, now, so how much work was done by the applied force on the trash can? So let's put another forces also, downward and upward, ha? Let's check lang talaga siya. All forces as much as you could illustrate so that we can understand further. Okay, going upward, okay, like this. Going upward and going downward, okay? Going downward, we have the weight, okay? And then we have also the force, of course, is equals to the weight. And our gravity is 9.81, okay? Directed downwards, 9.81 meter per second squared. Okay, okay. How much work was done by the applied force on the trash can? So, this is displacement thing, manggod siya. So, let's illustrate the displacement thing, ha? Not the force times distance only, because the problem really states the displacement, manggod siya. Okay, so work is equals to force times the displacement, small letter d, cosine theta. Charot, wait. Okay, cosine theta. Okay, so in here, what is our theta? Okay, what is our theta here? Think. Okay, let's substitute one by one. So force, okay, times the distance. Okay, okay, force times the distance. Oh my God, what's happening? Force times the distance. Force is equal to 50 Newton. Kaya applied man siya. Okay, how much work was done by the applied force? So 50 Newton. Okay? Like this. Okay, displacement, guys, is mentioned in the problem. Total horizontal displacement of 10 meters siya. So 10 meters. Okay. Cosine of 180. Because horizontal, as I said earlier, right? 180 degrees. Okay. So, how much force exerted? Okay, so cosine 180 negative, still negative. Okay, times 50 times 10. Negative 500 Newton meter. Again, don't be tempted with this negative. Okay? Because you pulled the trash can in the right. Okay, this is 500 joules positive. So, very strange like that, right? Nakakaloka. I don't like this. Okay? So, 500 joules. Positive na siya. It's not negative. Because you are pulling the trash can on the right. Not on the left. In the axis, it's negative. Manggod siya sa quadrant-quadrant effect in algebra. Okay, that is 500 joules. Okay, the answer is 500 joules. That is letter, ano ba dito? Letter A. Okay, ganon. Letter A. So, question number 2 in the same problem. These are what we call follow-up, follow-up questions in a problem. In the board examination, guys, there's also like this. Follow-up questions. For example, one long paragraph problem, then question number 1, question number 2, question number 3, and then for one number only. Ganon siya. Okay? So, next, what's that? How much work was done by a fractional force on the trash can? Oh my goodness. So, fractional force na siya. Since we know the fractional force of 30 Newton acts between the surface of the trash can, then substitute with the same equation. Actually, very easy because we're using the same formula, but it matters on the analysis. Okay? Like that. How you understand the, the situation. So, work is equals to fractional force, which is mentioned here, 30 Newton. Okay, like this. Still, you will be using the same displacement because it's opposing man siya. Okay, and take note, opposing biya siya ha. Okay, so 13 Newton times 10. Okay, like this. Okay, cosine theta. Okay, 180. Okay, cosine. Okay, cosine. Okay. Wait for a while. Unahon siya tuplok ang cosine. Sorry. So, syntax error siya if you will push the number first and then cosine. It should be cosine first, press, and then the number. In the calculator, sorry. That's why. Okay? Bubo kay ko. In fairness. So, like this. Now that is a fractional force, cosine theta. So, in this equation, guys, so, okay. So, what will be your choices? A, 500 joules. B, 300 joules. C, negative 300 joules. D, none of the above. Okay, none of the above. Oh my goodness. Okay, you pull this back to the right. That is positive. And then the fraction is opposing, that is negative. Okay? So, 30 times 10. Okay? And then, take note guys, the theta here is not 180 already. Okay? It is 0. Oh my goodness. Talaga? Okay. Because it is on the fraction side man siya. Okay? Like this. It's not the one who entails talaga ang word, the cover horizontal distance. It is the 180. It's the applied force magud siya. Because the fraction is just only waiting in the end. Okay? If I will push this one, during the action, there's no friction somewhere there because it doesn't stop pa man siya. Okay, it is moving, right? So the friction there is not considered. The friction there will be considered on the output thing. Okay? It only opposes in the resultant force after you apply the force, not on the moving situation. Okay? Because there's no friction at the moving situation because it is moving, it's in motion. You cannot expect friction there. Okay? Principle, motion, kinetic energy, there's no friction there. It's flowing directly. So our focus is during the stoppage there in the resultant force. Okay? So this in the fraction will be there. Ganun siya, in fairness. Okay, so our angle of inclination is equals to 0. Okay? Not 180. Correct me if I'm wrong. Okay? Like that. Because it's in the stopping moment siya. Because of fraction. Okay? Stopping moment. Or else, there's no fraction if it will not stop. Kaya nga, nag-oppose siya eh. Para ma-stop yung backs. Okay? Like that. Okay, so 30 times 10. Okay guys, 0 cosine 0. Cosine 0 is equals to 1. So 1 times 10 times 30 is equals to 300 joules. Ang answer is positive, supposedly. But it is opposing man siya in direction. That is negative. Okay, right man to siyang pag-pull niya. Ang fraction kay mukontra siya, opposing. So negative siya. Okay? Like this. If I pull to the right and the friction will go there, it's in here, right? Okay, so that's gonna be the clue there. So the fraction, you'll take note the direction of the fraction is going on the left. If the fraction will go on the left, so negative sign siya. So that is negative 300 joules is the answer. Okay, so this very important pala talaga yung displacement or the positioning or the direction here. If we consider the displacement, it's very important, the sign. Okay, like that. So this negative 300 joules, letter C. Okay, for this question, how much was done by a fractional force on the trash can? Charot. Okay, number 3. How much work was done by the gravitational force on the trash can? Wow. My gosh. How much work was done by the gravitational force on the trash can? Why like this, di ba? It's only vertical, but why there's a gravitational force? Nakakaloka. That's why it's gonna be like this kasi you have to think, okay, how much work was done by the gravitational force on the trash can? Still having the gravity because I think, okay, somewhere along the way, it's moving, okay? And then we need to think also that when it moves, there's a vibration. Okay, vibration. So there's also a little bit of gravity in going on the right. It's gonna be like that. My understanding is like only like that. Because why he is asking for the gravitational force, na in fact, the box is not dropped, is not lifted up. So that's my point. Okay, that's our theory, right? But since they ask this, let's analyze that during the pulling at the right position or direction, the box will undergo vibration. Ano ba? So when do the vibration, there's also a gravity somewhere along the way for that box to the surface. That's why it's being asked also, right? Okay, so we will use the work is equals to mass again times the gravity. Okay, the mass of the trash can is 5 kilogram. Okay, the gravity is 9.81. Okay, 9.81 meter per second squared. Okay, like that. So this is now Newton. Okay, the unit of weight or force. So 5 times 9.81 is equals to 49.05. Okay, so 49.05, so 9.81 again. Charot, okay? So I was afraid because the question it looks like not meeting the theory, something like this. Okay, but anyhow, okay, 9.81 times 5 is equals to 49.05. Okay, this is Newton. This is our force equals to the weight as the box will try to vibrate in a downward motion, upward and downward motion. Okay, like this. Okay, so 45 Newton. So use again the work is equals to force times distance, like this, blah blah blah, so and so. Okay, so work is equals to force times displacement times cosine. So if that is the case, guys, if that is moving downward a little bit like this, so this is no longer this is no longer 180. Okay, because the 180 is in the plane lang ng gid siya and horizontal. So I think it will consider also the downward and the upward. Since the downward and upward is 90 degrees, right? Oh my gosh. So 90 degrees plus 180. I think so. So let's try. Okay. So force 49.05 times the displacement. Okay, which is 10 ba to siya? Okay, 10. Okay. Times cosine 270 degrees. Okay, if you pull this by a rope, then somewhere along the way, it will vibrate man good siya. It will not go directly go there like this somewhere along the way. So if that is the case, we will consider also the angle of inclination going up and going down. So we will take a little bit of the 90 degrees. Okay, so 90 degrees plus 180 degrees. Okay, because it's in the ground. Ganun lang. Okay, let's try. Okay, so 270 cosine of 270. Okay, 0. Okay, 0. Cosine of 270 is 0. So 0 times 49.05 10 meters equals to 0. So the work will be 0. Oh my gosh, why like this? So Newton meter joules. Work is equals to 0. True? It's correct? Well, this actually is 0 there. Wait. How much work was done by the gravitational force on the trash can. A, 392 joules, B, 200 joules, C, 300 joules, D, 0 joules. So there's a 0 joules in letter D. So we will answer this 0 joules, right? Correct me if I'm wrong. 0 is the answer. And then let's justify this, why the work is 0. Okay? I think technically the work is 0 because the object is not moving downward and upward in the going to the final point of destination. Talagang lulusot talaga. Okay? And then, because this gravitational is upward man siya. Upward and downward. Since vibrate lang naman siya, so parang negligible siya. The force covered downward, weight downward. Like this, the microphone, like this only good. Vibration lang siya. So, it's not really covering a very high force and weight man good siya. So, parang negligible and irrelevant. Okay, so that's why the work is 0. Okay, so based na siya on the theory na siya ha, not on the computation. I'll just justify why the work here in the gravitational force thing is 0. Okay, because there's no gravity in that much irrelevant in pulling or in pushing the object, because this is not a downward motion. That's why it's 0. My gosh. And then if it is 0, then why you ask in the problem? So things like this, right? So actually, if I will make the question, I will not include this one because I know that in the first place that the object is being pulled only. But why I ask this, how much work was done by the gravitational force of the trash can? Meaning to say, it only measures the IQ of the student. If they really understand the principle and theory of the gravitational force, right? So it's gonna be like this, the point of the problem. Because actually no need to ask this because the work is automatically 0 because it is not downward and upwards, things like this. But still, they give this question like this to really measure the analysis or the comprehension or the understanding of the examinees and the students. Okay, especially in this kind of problem regarding force. Okay, the answer will be 0 joules. Okay, guys? Any questions so far? Okay, so thank you so much. If you really enjoy a lot in this problem solving, then you can comment down below in the comment section. You can like, okay, you can also comment anything you wanted to, anything you wanted to comment, okay? And then subscribe my YT channel if you're not subscribing yet. And then click the notification bell for some newest updates of I Am a Singer, Eternal Voice. Stay tuned and stay later for problem number 5 and onwards. Bye-bye. See you later. God bless. Talaga. Oh my God.